Okay, this is a continuation of lesson 1-2, and this is the second video, and this is example 4 on the bottom of page 15. This is just building on what we just did, and it's just a little more steps in the problem. Your videos will not always be this long, but today I'm trying to give you plenty of review as we go. Sometimes they will be this long though, so be a careful steward of your time. All right, so example 4 says, and I'm going to try to do this so you can, let's see, I think what I'll do is let you look at the map and I'll read the problem. The map shows the route for a race. You are 365 meters from the drink station R. So here's you, here's drink station R. You're 2 kilometers from drink station S. Here's drink station S, and here's the diagram showing that you're 2 kilometers from it. The first aid station, right here, is located at the midpoint of the 2 drink stations. The midpoint is halfway between R and S, or the mid station, the mid distance, the midpoint. How far are you from the first aid station? So we're going to have to combine some thought processes here. It's not complicated, it's just multi-step. The first thing we need to realize is that we cannot do a math problem when we have part of the problem in meters and part of the problem in kilometers or kilometers. So you're going to need to review something with me really quickly, and that is King Henry died Monday drinking chocolate milk. This is for converting our metric measures. King Henry died Monday drinking chocolate milk. We have kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. So the problem gave us I put it there, but that's not where it goes. They gave us 2 kilometers or 2 kilometers. We need to move that to the meter spot so that it matches the other part of the problem. So we're going to change from kilometers to meters. That is an easy thing to do in the metric system. All we do is move decimals as we go. So here's our decimal now, but as we move to hectometers, that's 1 decimal place moved, decameters is another, and meters is another. So that means our decimal is now way over here, and we created a spot for a 0 there, there, and there. So from kilometers to meters is 2,000 meters. So really, this is multiples of 10 that we're dealing with. So we are multiplying by 10 every time we move. So 2 times 10 would be 20. 20 times 10 would be 200. 200 by 10 would be 2,000. If we kept moving, we would keep multiplying by 10s and adding a 0, or moving the decimal and adding a 0. If we were going the opposite direction, we would move the decimal place in a different direction, and we would get rid, well, not exactly get rid of, let's try it. We would add zeros after the decimal and before the number. So here's our decimal now, but as we move to centimeters, we're going to have a 0.2. That's supposed to be a decimal. As we move to decimeters, it would be 0.02, and so forth. So this time we're dividing by 10s. All right, so let's go ahead and look at the problem. The problem asks us how far you are from the first aid station. Now remember, this is really 2,000 meters because we converted it. 2,000 meters. Let's figure out first what RS is, because the only way we're going to figure out what the halfway point between R and S is if we figure out what the whole thing of RS is. So we're going to use our segment addition postulate, and we're going to say XR plus the whole RS equals the whole entire distance, which is XS. So let's do that part right here. XR is 365 plus RS equals 2,000. Obviously, all we're going to do here to solve for RS is to subtract 365 from 2,000, and that is going to equal 1,635, or 1,635. We now have our distance for RS. They want to know where this is. It's the midpoint. That means it divides it in half, in the middle. So we're going to just divide this distance by 2, and that is going to be, I'm looking, give me just a second, 817.5. That means that the distance from RY is 817.5. It's also the distance from RS, because this distance is equal to this distance. Midpoint always makes the two sides equal. But now, again, that's not our final answer. You always have to go back in geometry and say, what was the actual question? How far are you from the first aid station? So we're going to say our distance from the first drink station plus our distance from the first drink station to the first aid station is 817.5 meters, because that's what we were working in. 817.5 meters. All right. I think that we have one more quick thing to do in this lesson. This is on page 16. This is example 5, and we're using a couple of things here. We're using some of what we were working on when we were using the segment addition postulate, and we're using what we just used with midpoint. So I want us to learn a couple of words really quickly. Let's go back to page 15. 2 words in this paragraph above the last problem we did. The midpoint is the point that bisects or divides a segment into 2 congruent segments. So the midpoint of AB, which is what they're telling us right here, the midpoint of line AB is going to be the point right in the middle that bisects or cuts in half this line segment into 2 equal parts. Now that was one of your vocab words. Actually, each of these were one of your vocab words. So the midpoint is the point in the middle. Bisects means it cuts it in half or into 2 equal parts. Those are going to be super important words to know as we move forward. All right, so if this, let's call this M, the midpoint. If AM was 3, what would MB have to be? Well, it would also have to be 3, because those 2 sides have to be equal if this is truly in the middle. And what would the whole line segment AB be? Well, it would actually be 6, because the 2 sides added together equals 6. So now let's go look at a problem like that. Next page, page 16, example 5. Using midpoint to find lengths. They tell us in the problem, B is the midpoint of AC. You can see that right here. B has been drawn in between A and C, and they're telling us that it is the midpoint, or the very exact middle. They tell us the measurement for AB is 5x, and the measurement for BC is 3x plus 4. They want us to find AB, BC, and AC, the whole thing. How are we going to do that? Well, we're going to use some algebra here. We know that this is equal to this because of the midpoint theorem, or the fact that B is the midpoint. So let's try making that equal. 5x, let's make it algebraically equal, is equal to 3x plus 4. 5x is equal to 3x plus 4. Now we're simply going to solve for our x. We're going to move the 3x to the other side, subtract it from both sides, and this is going to be 2x equals 4. Then we're going to solve for x. We're going to divide both sides by 2, and x equals 2. Now we have what our x equals, and we can do what the problem actually asks us to do, and that's finding out the value of each part. If x equals 2, then 5x equals 10. 5 times 2 equals 10. BC, 3x plus 4, 3 times 2 is 6, plus 4 is 10. So we have AB is 10. We have BC is also 10, which of course that had to be true because B was the center or the midpoint. And now to find the whole length of AC, we say 10 plus 10 is 20. So that's the final answer to our problem. And we would write it this way. In your homework, you would need to say line segment AB equals 10, line segment BC equals 10, line segment AC equals 20. You wouldn't have to necessarily do all of this because a lot of that you could have done in your head. All right, that is the end of lesson 1-2. I'm going to start a third video for the things that we did not get to in lesson 1-3, so stay tuned for that.